Okay, so let's do carbon dioxide. That's the fourth one we're doing, CO2. We need to account for how many valence electrons, so I'll abbreviate valence electrons for carbon. We also need to know the valence electrons for oxygen, and there's 2 of those. And then we're going to add all of that together to get the total. Remember, math and science are siblings. You show work for one, you gotta show work for the other one. Okay, so we're gonna find these numbers. Let's go look over here on the periodic table to see what's going on. We know both of them are non-metal, so they're gonna be on the right side. Okay, we can count stuff, or we can look at some of the headings up here. Okay, oxygen is going to have 6 per each one of those. So it's 6, there's 2 of them. 6 times 2, 12. I'll write that in a second. The other thing we have in carbon dioxide is carbon. There's 4. Okay, so 4 for the carbon, 6 for both of those oxygens. So write that down. And we're going to remember that there's 2 oxygens, not just 1. So the answer is not 10. So for the carbons, there's 6. Misspoke. There's 4. For the oxygen, there's 6, but there's 2 of them, so 6 times 2. That equals 12. Let's just move this guy over. So there are 16 electrons that I need to use when I'm doing my diagram, okay? So we need to keep that in mind when we're doing things, okay? So let's draw it out. I'm going to move to another board to do that. And again, it's going to work exactly the same. It doesn't matter that there's going to be different letters representing the different elements. We'll still follow. Draw your valence electrons, connect the ones that are by themselves. They don't want to be lonely. There's people there for them to hang out with. So we're going to go, okay, carbon's over here. And then notice that there are more oxygens than carbons. That's one of the indications of who is the central angle. So it's like carbon's the center of attention. Just line them up at the beginning. Okay, so we're going to go like this. Each oxygen needs to have 6. So we're going to go around. We're going to go 1, 2, 3, 4, 6. Carbon needs 4. 1, 2, 3, 4. Oxygen with the 6. 1, 2, 3, 4, 5, 6. And let's start connecting people. Since he's in the middle, the oxygen should connect to that one. Okay, they're not going to go, oxygen is going to pair up with that one. No, you need to go closer. You're not going to ignore and be mean and ignore people who are right here on the dance floor and go to that one. So this one goes with that one. This one with this one. This one grabs that one. Everything's nice and balanced. Notice how there's going to be double bonds in between this carbon and each oxygen. This is our rough draft. Essential and things that I want to see when you're doing it, so I know what were you thinking about as you got to your final. So our final draft. Well, we know the carbon's in the middle. We know the oxygen is right here. There should be doubles because these got paired off. They're sharing them. Okay. But there was already 2 couples on the oxygens right there. Okay, and it stays nice and straight. Notice this one's also linear. Okay. And in this case, for our second thing that you're going to be drawing, if you want to color code it, you can. I'll just change up the color for the oxygen. You can keep it all in one color, doing pencil or one color pen. It's going to be like this. So this is the Lewis dot structure. This is like our VSEPR. We'll talk more about VSEPR, but I want you to get acquainted with this acronym as we keep on going, okay? Now we're going to get to our next one, and again to remind you, there's spots for you to be uploading things on your Google Doc, namely right there. Put your Lewis dot structure, your VSEPR, the thing we just drew, the red and blue thing, and then we're going to go and we're going to do water. Well, we're here in front of the board. Okay, to remind you, hydrogen's to the left. This one's not too helpful with, well, 11A is not going to help you, but we should know, okay, hydrogen, element number 1, 1 proton, 1 electron. Okay, that's all hydrogen has. So it's gonna have one electron. Oxygen we just did, just to remind you, that one, yes, on the right side, you can use the little heading thing. 6 per each, per that one, per that oxygen. So we're gonna have one apiece for each hydrogen, that's 2, and then 6 over here. Let's write that down for H2O. H2O. There's less of this one, so that one is the central element. Will be right here. The central atom will be right there. And again, let's just line it up nice and straight, and we're gonna talk about stuff. Okay, so we know this guy has 6. The ones on the edges, but let's take a count just so you get into the routine of it. Okay, so the electrons, the valence electrons for hydrogen. Well, there's 2 of those. 1 times 2 is 2. The valence electrons for oxygen equals 6. We add and we get 8. Okay, so total valence electrons equals 8. Okay, so now let's put that over here on our Lewis dot structure. Hydrogen has 1, hydrogen has 1. Let's do 6 over here. 1, 2, 3, 4, 5, 6. Again, whoever's in the middle, they're going to bond with the ones on the edges, okay? You're not going to go hydrogen and skip over people. So he's going to go with that one, he's going to go with that one. Cool. Let's do another draft over here to see what's going on. Notice I'm not jumping to the final draft. Let's do a second draft. On this one, hydrogen's a little bit tricky. Things get more complex. It's not as simple. Not be like playing the same type of music all the time. It's gonna get boring. This should make sense, and then hydrogen has. You can put one there, one there. That'll be fine. Okay. But we can do a better Lewis dot structure than this. One thing we want to take into consideration is that this guy right here, these electrons right here, we're basically gonna push that down. Right there, and they're going to bend it. So our final draft for our Lewis dot structure is actually going to end up being, it's going to have its angle down here. Later this week we'll talk about, okay, how do I figure out what that angle is, and we'll remember. So then we can do a little bit of math, things you've seen maybe with me or Joshua in math classes. Okay, so it's going to look like this. This shape is called bent, and if we want our ball and stick, and go like this with the oxygen. It has the hydrogens coming off of it. Okay, like that. There are electrons coming below. We'll keep it like this to keep it clean. The reason why it's bent again is these electrons are pushing it down, and this has become polar. It's not nice and balanced like the carbon dioxide was. Okay. Let's go on to our next one. Let me take a peek at what that one was. So again, insert your diagrams onto the document. Now we're going to do an ion. This one has more details. We have talked about ions before. Okay, this one's sulfide. Notice there's a little number there. Remember the charge is up there. Let's take into account for the sulfurs, 3 oxygens this time. The little 2 negative is going to add 2 more electrons to get our total. Okay. And just to remind you, refer to your periodic table. Okay, so sulfur, group 6. Okay, so both sulfur and oxygen are 6s, so it's going to be a bunch of 6s. Just keep into account. And notice the little message I put to you right here on your document, if you're actually looking at it in bold. I want you to pause the video to see if you can figure this one out. See how close you are. Notice after you've drawn all your stuff and you watch me work through it, and again, do pause. It's to your benefit. It's going to challenge you. I want to see how much of it can you do. You may surprise yourself. I think most of you will be able to do most of it. If you get it completely right, you're going to highlight yes. If you notice, okay, you're way off, none of the stuff worked, I doubt any of you is going to be that if you actually have been watching and trying from the beginning. Or I was close. Maybe you messed up or you got stuck at the end, you did most of the problem. So pause it right now so you can see how well you do. And actually I'm going to make it into another video, so you have to click over to the next one. Okay?